Hello everyone. We are from the group 37 of the laboratory of the embedded system. So for the final project, we'll be making a vehicle-based traffic light controller. The member of our group is myself, Robbiarsya S.A. Next.
My name is Naufal Aulia Amanullah.
My name is Abyaz Oktora.
And my name is Erfigo Smaradheva.
Okay, next slide. Okay, maybe when you are riding your car or motorcycle and you cross an intersection, and you will see a traffic light. Have you ever wondered how a traffic light controller works? So for this final project of the embedded system laboratory, we'll be making a vehicle-based traffic light controller, and we will know how a traffic light controller works. Next. So for the contents of this presentation, we'll be talking about the background of our final project, the description and the components of the vehicle-based traffic light controller, the flow chart, and the source code. Next.
So now I'm going to explain the background of this project. So this project has the ability to detect vehicles on each side of the intersection or junction. If there is no vehicle at one side of the intersection, the system will skip that traffic light signal and move on to the next one. So the Arduino Uno is an integral part for this project, and the ultrasonic sensor HCSR04 will be used to detect and calculate the distance of the objects. The objects here will be the vehicles. The distance will tell the system if any vehicle is near the signal, and according to that, the traffic light signals will be controlled. Then the red, yellow, and green LEDs are used for the traffic light. The system will log based of the time and the distance of the vehicles.
Okay, so these are the components that we use in this project. For the Arduino Uno, we use as the development board, and then to produce the time, we use the real-time clock here, and then for the traffic light, we use the LED, green LED, yellow LED, and red LED. And the next. Okay, so and then the next one is the left one is POT. This is the variable resistor. This variable resistor is used to modify the range between the sensor, ultrasonic sensor, and the vehicles. If it set to the higher resistance, means the distance from the sensor to the vehicle is very far, and then but if the resistance is low, it means that the sensor, the range of sensor and the vehicle are close. Okay, and then the next one is the resistor 220 ohm. This is used as to prevent overcurrent to the LED, and then okay, and then the next one is SD card. This is used for storing the data log. Okay, next. Okay, and then the ultrasonic sensor. This is used to measure the distance between the sensor and the vehicles. And then the last one here, this is the virtual terminal. This is used to print the output in Proteus. Okay, next.
And the next one, I will explain about the flowchart of this project. So first, we declare the input and output of the ultrasonic sensor of the master Arduino. So in this project, we will use two Arduinos since the input and output is not available in only one Arduino. So we use two Arduinos and we apply the I2C connection. We apply here the include wire.h to declare wire.begin. Here wire.begin is important to be declared in the master Arduino, and we declare the trigger pin as output and echo pin as input. So the ultrasonic sensor from before contains trigger pin and echo pin, and we will going to digital write the condition high or low of the trigger pin and push in the echo pin. Push in the echo pin here means that to calculate the time where the echo pin turns from low to high. And the next one is after that we will calculate the duration based on the time of the push in of the echo pin here, and we will be using function to convert from microseconds into centimeters, and we declare the state address to begin transmitting distance. So there are 4 distance that will be given, and we declare the LED output pin of the Arduino here. This is the basically is here from here. This is the different code, the slave Arduino code, and we declare the threshold, the distance at 5 centimeters. So at below 5 centimeters, it will be applied function that directly connected to the LED pins, which is the red, green, and yellow light pins based on the junction of road. And the yellow LED and green LED will be activated using delay if it is below the 5 centimeters. So if it's below 5 centimeters, then basically there is vehicle in front of the light. So the green LED will be activated and the yellow one. And if it's more than 5 centimeters, then it will display the low mode, which means only the LED red LED that is activated. And if we give an option here, if both of them, if you want to turn off, then you just cut the connection and if you want to continue, it will loop back to this path. It will read again the trigger pin and the echo pin based on the condition and the amount of pulse in the echo pin of each 4 ultrasonic sensors. Then we will continue to the source code and the demo. And so we begin the source code explanation. Here we use 2 codes. There is the master code and the Arduino code. Here is the master code. We use this includes basically the wire.h for the I2C communication is important, and sd.h and rpc.lib. Rpc.lib is to measure the time, and the set address here is 9. And we define the pins here and define the other variables. You can go down. And in the setup, we declare the wire begin, and we declare the serial begin 99600 and also the pin modes. And this is the code for the SD card. And let's continue to the loop. And this is where the trigger pin and the echo pin of each ultrasonic sensor. There are 4 ultrasonic sensors that will explain that will give the duration based on the pulse in, and it will calculate the distance based on the microseconds to centimeter function. And there is delay, and it will be displayed in the data log of the SD card. You can continue down. Here the code is for all 4 of the ultrasonic sensor. And let's continue to the wire begin transmission. Here, this is important to transmit the data of S1 until S4. This is all the distance that is given by the ultrasonic sensor. It will be transmitted to the safe Arduino with the delay of 1 second. And this is the RTC display to display the time that is given by the rtc.library. And this is the long microseconds centimeters, the function to convert. And now we continue to the slave code. Here, this is the include. Basically, this is the same wire.h as the master code, and we define the delay times of the green light and the yellow light. And the slave address here is the same as in the master code, and the distance is 5 centimeters. Here is the signal of the LED pins. Basically, this is representing of the red light, green light, and yellow light. Red light, yellow light, and green light in order. And this is the setup. We accepting the transmission address by wire that begin of slave address 1, and we use the wire on receive to receive the information, the data from the master. This is the pin modes, and this is the receiver function. We read the data that is given by the master, and this is the void loop, and this is the signals. Signals is the main function, and this is the void signals. So here, if all this distance is below the distance threshold of 5 centimeters, it will run the function, which is the signal 1 until 4 function. And we continue to the signal 1 function. Here is the low, and low means to create red LED that is high, and the other LED is low. And this is the digital write of the red one and the green one, low high. And after that, it will display the yellow light with this code, signal 1 to low, signal 1 high, with the delay of yellow delay. And basically all the 4 function is the same. Let's continue again to the down, and this is the low function to display the low LED for the red LED, high red LED, and the others will be low. And with delay 1 second, it can be applied in the circuit.
Okay, now we set all the variable resistor to the lowest, which means that the range of the between the sensor and the vehicle is very close, so it will act as the normal traffic light. It will go sequentially. And then I set the high resistance in side 3, so there is no vehicle in this in this side. And if there is no vehicle in this side, it will jump from, it will be skipped. So the sequence will goes from the side 2 to side 4. So you can see here, it will jump from the side 2 to the side 4, because the side 3, it has there is no vehicles within 5 centimeters.
So that's all the explanation of our final project. Thank you very much.